So we take a look at our first example. What we want to do, ultimately, what we're trying to do is we're trying to figure out what does x equal. And in this particular case here, what we've got is we've got a rational equation that has numbers for denominators, which is nice. We'll get into the variables, but we've got numbers right now. So the first thing that we need to identify is what's the least common denominator between 2, 6, and 6? And if you don't know, ask yourself this question. Will 2 go into 6 evenly? Yes. So our least common denominator is 6. Well, what our directions say back here on this first page here is that a rational equation, or to solve this kind of equation, multiply each side of the equation by the least common denominator. Well, what if we just figure out, what if we combine these two over here on the left first? And the common denominator between 2 and 6 is still 6. So this would be 5 minus 2x, and then it's 2 times 3. That gives us 6. And then what happens is, what did we put into the denominator that wasn't there before? We put in there 3. Don't cancel out anything. So I wrote it a little bit differently from the way I've been writing it. And here's our 3 over 3, because 2 times 3 is 6. And we're going to subtract from that. And in fact, I'm going to change that color because we need to be careful. I'm going to subtract from that 4x plus 3 over 6. So I'm ignoring the right side of the equation for a minute. Gives us more practice on subtracting, which we need more practice on subtracting. And I'm going to add a step in here. So it's 5 minus 2x times 3 minus 4x plus 3. And here's where we have to be really careful. We're subtracting 4x plus 3. And that means that that negative sign applies to the entire numerator, the entire top of the fraction. And now it's divided by 6. So that's our common denominator. 2 times 3 is 6. Over here is 6. Don't have to write that step, but I still recommend it. If we simplify this a little bit more, we're going to use distributive property. We get 15 minus 6x. Now it's minus 4x minus 3. Because we distributed the negative, all divided by 6. And then when we combine like terms, 15 minus 3 is 12. Minus 6x minus 4x is minus 10x divided by 6. That's the left side of the equation when we subtract it. But we still have this right side of the equation. It's 7x plus 2 over 6. And now that we have one fraction on the left and one fraction on the right, what we can do is we can cross multiply. When we cross multiply, we have 6 times 12 minus 10x equals 6 times 7x plus 2. But you have to have one fraction on the left and one fraction on the right to be able to do that. Now, as we take even a closer look here, we can make our lives a little bit simpler. Because what if we divide this side by 6 and we divide this side by 6. What happens to the 6's? They cancel out. We don't even have to distribute. And you could have distributed. We have 12 minus 10x equals 7x plus 2. You with me? We canceled out the 6's because there was a 6 on the left side and there was a 6 on the right side. So we were left with the 12 minus 10x on the left side and the 7x plus the 2 on the right side. And now we can solve. Solve how your Algebra 1 teacher taught you to solve. I like to move my letter to the left, so that's what I'm going to do. But that's probably not how your Algebra 1 teacher taught you. Going to subtract 7x from both sides. Going to subtract 12 from both sides. Then we get negative 17x equals negative 10. And then to finish, we want to know what does x equal. Dividing both sides by negative 17, we end up with x equals 10 17ths. And that was the first one that you've seen like that. Let's try another. The nice part about example 1 is that there were only numbers in the denominator, and that's what's going to be different here on the remaining questions. As we look at example number 2, let me suggest that we just work on the left side of the equation for a couple minutes, finding our common denominator. And once we get the left side of the equation simplified, then we can cross multiply and we can figure out what does m equal this time. So the first question is, what's the common denominator between 5 and 3m? And hopefully you're thinking 15m. 5 times 3. 5 is a prime number, 3 is a prime number. We multiply them together. And then we have the m. And I don't need that yet, but I do want to make that minus sign. We need to be careful with the minus. So on our first fraction, the 1/5, originally we had 1 in the numerator, and now it's 15m. Not only did we put an m into the denominator, but we multiplied by 3m. 5 times 3 is 15m. And on our next fraction here, I want it to be in red there. We had the 4. Now our denominator is 15m. What did we multiply 3m by to get 15m? Well, 3 times 5 is 15. Now we found the common denominator. Don't cancel anything here because we need a common denominator. The subtraction is not quite so bad compared to the last one, conceivably. 1 times 3m is 3m. 4 times 5 is 20. All divided by 15m. Remember, that's the left side of the equation. So we've combined the left side into one term. Now our right side is 2 over m. Well, we've got it into one equation on the left. Sorry, one fraction on the left, one fraction on the right. We can cross multiply. Here and here. So we get m times 3m minus 20 equals 2 times 15m. seems that I was a little bit confusing on the last one, so I'm not going to cancel anything out here. But if you wanted to, you eventually could cancel out the m. But I'll just try it this way. M times 3m is 3m squared. And minus 20m. Over here, 2 times 15m is 30m. And now we want to solve. We want to figure out what does m equal. Well, we've got a squared in this problem, so that probably means that we need a factor. And in order to factor an equation, we need to have the equation set equal to 0. So we get 3m squared minus 50m equals 0. And what we, I hope, see, and it's small, so it's harder to see, but that we have a greatest common factor of m. And we're left with 3m minus 50. Well, finally, we're going to set each of those factors equal to 0. We're going to set m equal to 0. We're going to set 3m minus 50 equal to 0. So we have one value for m. Over here, let's add the 50 to both sides. 3m equals 50. And then it's 3 times m. The inverse operation is to divide. And we get 50/3. Here's the thing. We can have 2 answers to the problem. But in this particular case, one of them is an extraneous solution. And in this particular type of problem, globally, this type of problem, if one of these values causes our denominator to be 0, then it's an extraneous solution. When 0 is underneath, the fraction is undefined. And if it's undefined, we can't work with the problem at all. Well, when we go back and look here, if we just go to the right here, 2 over m, well, 2 over m is 2 over 0. But we are not allowed to have a 0 in the denominator. So this 0 here is extraneous. I usually write ext for extraneous. And I usually just do one line through it, because I would still look and see, did you have that answer? 50/3 is not going to make our denominator, either one of them. 3 times 50/3 is 50. And then over here, 50/3. The only value that's not allowed to be in the denominator is 0. So our solution to this problem is going to be 50/3. Problem number 3. Let's look at the left side. Let's add those two together. So we'll start there. Common denominator is going to be determined by simply multiplying the two together. X plus 5 doesn't have anything in common with x minus 9. So we have x plus 5 times x minus 9. And if there's anything good, it's that we're adding these together in this particular problem. And we can ask ourselves, do we have anything in the denominator that wasn't in there before? Well, the x plus 3 is still there. And then we have our x minus 9. Same way on the next fraction, our 2 is still in the numerator. The x minus 9 was already there, and now we have an x plus 5. we currently are trying to combine the left side of this equation with the common denominator. So on our left-hand fraction, now what we're going to do is we're going to FOIL. We're going to get x squared minus 9x plus 3x minus 27. First, outer, inner, last. With our right-hand equation, we have to distribute. And we end up with plus 2x plus 10. All divided by our common denominator of x plus 5. Times x minus 9. Let's combine my terms. We've got x squared. And then we've got negative 9x plus 3x plus 2x, which is negative 4x. We have negative 27 plus 10, which is negative 17, all over x plus 5 times x minus 9. And all that we've done so far is we've combined. We've added together the left side of the equation. We still have this right side of the equation, which is 2 over 2x plus 10. Now, as we take a look at that left-hand fraction, can we do anything to that? Let's take out a 2. And here's how we can take out a 2. We can deal with that greatest common factor of a 2. Greatest common factor of the denominator is a 2. And then, do we have anything exactly the same on the top and on the bottom? Yes. So simplifying that a little bit more is helpful. We have x squared minus 4x minus 17 over x plus 5 times x minus 9. And on this side, remember, 2 divided by 2 is 1 over x plus 5. Now we have one fraction on the left, one fraction on the right. We can cross multiply. And we have x squared minus 4x minus 17 times x plus 5 equals 1 times x plus 5 times x minus 9. No, you don't have to write the 1. But what can make life a little bit easier in this problem is noticing that we have an x plus 5 on the left side of the equation and we have an x plus 5 on the right side of the equation. And because we have something the same on both, we can divide by x plus 5 on the left, and we can divide by x plus 5 on the right. And x plus 5 divided by x plus 5 is 1. X plus 5 divided by x plus 5 is 1. And now that leaves us with x squared minus 4x minus 17 equals x minus 9. Once again, let's look at the left side. Let's find our common denominator. Eventually on the right side, we're going to be able to factor that denominator. And our common denominator is going to be x plus 4 times x minus 1. good practice when it comes to the subtraction. And what did we put into the denominator that wasn't there before? On this left-hand fraction, we put in there an x minus 1. On our right-hand fraction, we put in here the x plus 4. And be really careful because we're subtracting. Whenever we're subtracting, I like to do an extra step. It's up to you whether that is something that you need to do. This is x times x minus 1 minus 2 times x plus 4. And oftentimes when we write it in that format, we have less chance of making a mistake than when we have the previous step. All over x plus 4 times x minus 1. Well, our distributive property gives us x squared minus 1x. No, you don't have to write the 1. Minus 2x minus 8. All divided by x plus 4. And x plus 1. Well, we simplify a little bit more, we get x squared minus 3x minus 8. And as we take a look at that numerator, the top of the fraction there, the question is, can we factor x squared minus 3x minus 8? Remember, the factors of 8 are 1 and 8 and 2 and 4. Will they ever combine to be 3? Can't factor it. But what we can factor is the denominator here. Over here on the other side, we've got 20 over the x squared plus 3x minus 4. So 1 times 4 is 4. And the factors are 1 and 4 and 2 and 2. Which of those combines to be 3? Somebody said it. Negative 1 and positive 4. So I'm going to carry that down. And we set it equal here. We've got 20 divided by x minus 1 and x plus 4. Now that we have the equations down into one fraction on the left side, one fraction on the right side, the nice part is that we have a common denominator everywhere. So when we cross multiply, it's kind of an extra step, but when we cross multiply, we've got x squared minus 3x minus 8 times x minus 1 times x plus 4. We scoot that over. Equals 20 times x plus 4 times x minus 1. And once again, like we've done on previous problems, we can divide by x plus 4 times x minus 1, and we can divide by x plus 4 times x minus 1, and do we have anything exactly the same on the top and on the bottom? And you can see we canceling them out. And for some of you, you're not even going to have to do that. Now that there's a common denominator, what we need to deal with is the x squared minus 3x minus 8 equals 20. We need to deal with the numerator. And when we subtract the 20 from both sides, So I had to pause for a moment. So going back here, we're subtracting the 20 from both sides so that we can get this equation set up so that we can factor. Remember, I got to get it's 3x here, set up so we can factor. And the factors of 28 are 1 in 28, 2 in 14, 4 in 7, and we ask ourselves, well, any of those combined to be 3, either adding or subtracting to be 3, and they will. So we've got x squared minus 28, and we have plus 4x minus 7x, and we group. Well, we have x times x plus 4 minus 7 times x plus 4. So when we factor, we have x plus 4 times x plus 7. And then we have x plus 4 equal to 0, x minus 7 equal to 0. We're setting each factor equal to 0. And we can subtract 4 from both sides. Get x equals negative 4. We can add 7 to both sides. We get x equals 7. But lastly, we need to check and make sure that these answers are not going to give us a value of 0 in the denominator. They give us a value of 0 in the denominator, and we have an extraneous solution. So I'm going to go all the way back to the beginning, and remember our first answer was negative 4. Well, when we go to the very first fraction, in the denominator, negative 4 plus 4 is 0. That means that negative 4 is an extraneous solution. We cannot even work with the problem because if the value for x is negative 4. Well, when we go back and look at 7, looking at the denominator, bottom of the fraction, 7 plus 4 is 11. That's allowed. 7 minus 1 is 6. That's allowed. 7 squared is 49 plus 21 minus 4 is not going to give us 0. So 7 is our solution to this problem.